Okay, this video is going to be a little bit of 5, 6, 5, 7, and then 7, 1 to 7, 3 review, so triangle similarity. So a little bit of 5, 6, 5, 7, listing the angles from largest to smallest. So I'm doing angles, largest to smallest. So remember, small angle sits across from small side, big angle sits across from big side. So if I'm doing largest, I need my biggest one. So my biggest one is 3.1, and it sits across from angle C, so it should be my largest angle. Okay, if I go down, 3 sits across from A, and then my smallest is 2.9, which sits across from angle B. Okay, this time we're doing sides from smallest to largest, so I need the smallest angle first. Well, I need to find this angle here to be able to do it. So if I add my two other ones, so 61 plus 54 is 115. There's 180 degrees in a triangle, so if I take 180 minus that 115, I get 65. So my smallest angle is 54, and it's across from MO or OM. Okay, my next biggest is 61, and it sits across from NO or ON. And then my largest is O, and it sits across from MN or NM. Doesn't matter the order on that. Okay, determine the shortest leg. So first off, let's find our missing angles. So if I do this triangle here, I do 61 plus 60, which is 121. 180 minus 121 gets me 59. Now I got to do this triangle. So 55 plus 65 is 120. 180 minus 120 is then 60. If we're finding the shortest leg out of the whole thing, let's find the smallest angle. Well, 55 is, so you would think AC would be the shortest leg. The problem is it also sits across from 61, which automatically cancels it out from being the shortest. So we bump up to the next shortest, which is 59 degrees here. So it's the next smallest angle, and it sits across from DC or CD. So that would be my smallest side out of the entire figure, because the other one got canceled because it sits across from the 61 degrees. Again, the given lengths make a triangle. Okay, so for this, you have to add your two smalls together and see if it's bigger than your biggest one. So 7 plus 8 is 15. So yes, this would make a triangle. My next one, my two small are 8 and 12. 8 plus 12 is 20. 20 will never be bigger than 20, so no, it does not make a triangle. Find the range of possibilities for the variable. Okay, so this one, remember, big angle sits across from the bigger side. So if I look, 23, okay, so 23 is bigger, which means this angle 75 should be bigger than the angle x minus 13. So if I solve this, we're going to add 13 to get 88. Okay, so anything, if I wanted to flip-flop it, I keep eating the 88. Anything that's less than 88, or it's going to have to be bigger than 13, because 13 minus 13 would give me an angle of 0, okay, would work if I plugged it in. So this one, we're solving for x, so we're going to have to cross multiply because there's an equal sign. So I got 5 times 5, which is 25, set equal to 8 minus the entire other side, the entire top of the other side, because now when I distribute, I get 8x plus 16. Make sure you multiply by that whole thing. So when I solve it, let's go ahead and subtract 16 and divide by 8. So 9 stays on top, and 8 goes on bottom. Okay, so this time we got 40x equals 16 times that whole bottom side. So when I distribute, I should get 32x plus 16. We need our x's on one side, so we're going to go ahead and subtract this guy over to get 8x. Divide by 8 to get rid of it, so x is equal to 2 this time. Okay, the three angles of a triangle have an extended ratio of 2, 3, 5. Find the measures of all three angles. Well, I'm talking about angles and a triangle. All angles should be adding to be 180 degrees. So when I add all of the angles, it should be 180. So we're either setting these up as a proportion, or we're adding all of them using the same variable and setting it equal to a total number. Okay, I have not taught where we set up fractions when I have three different numbers. So we're most likely going to be adding them and setting it equal to our total number. So 2x plus 3x plus 5x equals my total of 180 degrees, because all the angles should add to be that. If we add all these together, I get 10x equals 180. divide by 10, so x is equal to 18 right now, but I want the measurement of all three angles, so I need to plug this x back in to all three angles to solve it. So 2 times 18 gets me 36. 3 times 18 gets me 54. And then 5 times 18 gets me 90. So there are all three of my angles. Okay, in a rectangle, the ratio of width to length is 3 to 10. So remember, it goes width to length, written in the order it's written in. If the length is 45 inches long, what is the width? I'm not giving you a total, so we're going to set up a proportion this time. Here is my first fraction. So I got 3 over 10 equal to, the other information I gave you was length, so we need to make sure the length stays in the same spot. So it looks like it's on the bottom, and I don't know what my other width is. So both lengths are on bottom. So when I cross multiply, I got 45 times 3, which is 135, and 10 times x. So when I divide by 10, x is equal to 13.5 inches, which would be the width then. Okay, solve for x and find the scale factor. So to solve for x in this, we're going to have to set up a proportion. So let's say I pick 14. 14 matches with 9.8 in my other polygon. And then since I started with my big one, I need to start with my big one again, so 11.5, which matches with x. We're going to cross multiply to solve it, so I got 14x equals 9.8 times 11.5 gets me 112.7. Divide by 14. Okay, x is equal to 8.05, so I'm going to cross this little guy out and put 8.05. Okay, it looks like I'm going from LMNO to RQTS, so I'm going this direction, so it's getting smaller. If you can't tell by the picture, if I look, 14 goes to 9.8, so it's getting smaller. So if it's getting smaller, my scale factor should be smaller. Okay, so if I pick, to find the factor, scale factor, remember we have to set up our proportion, so let's do 9.8, so I'm going to start with my tiny one on top, which matches with 14. 8.05, which is the x I found, which matches with 11.5. So when I divide them, I get 0.7 and 0.7. So my scale factor is 0.7. Well, is that small? Is that, if I multiply something times 0.7, is that going to get me a small scale factor? It is. If I would have gotten something like 1.2, that's not a small scale factor. If I multiplied it by 1.2, it would get bigger. So we got to flip-flop our fraction in that situation. But this situation, we picked the right thing to be on top, so my scale factor is 0.7. Okay, my next one, we got to find x, so let's say 15 over matches with 10, and then 14 matches with x. So when I cross multiply, I got 15x equals 140. Divide by 15, we got x is equal to 9.3. So I'm going to take this out and put 9.3. I'm going from XYZ to this one. So if I look, I go from 15 to 10, so I'm getting smaller. So my scale factor should be small. So let's say I start with 15, which matches with 10, equals to 14, which now matches with 9.3. If I take 15 divided by 10, I get 1.5. And this is also 1.5. That's not a small scale factor, so I need to go back and I need to flip-flop these and actually do 10 over 15 and 9.3 over 14 and see what I get. Okay, this scale factor is 0.67 and 0.67. That's the scale factor that I want because I'm going from a big triangle to a small triangle. Okay, we're trying to decide what shortcut I have, so I got angle-angle similarity, I got side-angle-side similarity, and side-side-side. So first off, I got my teeny triangle, and I got my big triangle here. So if I'm doing it, looks like they share H completely, so there's an angle. Now we got to check our proportions, so our sides, because I don't have parallel lines, so I can't say corresponding angles. Remember, if you have parallel lines, you got corresponding angles or alternate interior angles. Okay, so let's check our sides to see if they're proportional, because remember, these could be congruent, but they need to be proportional too. So I got 50, which matches with, on my entire length of my big one, I have to add them to get the entire length. So 75 equals to 40, and my entire length of this one, so 40 plus 20, which is 60. So 50 divided by 75 is 0.67. 40 divided by 60 is 0.67. So if I have a side, an angle, and a side, I could say side angle, side similarity. It looks like H matches with H, E matches with I in my teeny one, and F matches with G in my teeny one. So you have to double check to make sure that they're actually proportional to say side angle, side. Okay, in this one, it doesn't look like we have any angles, so we're going to see if our sides are proportional. So 30 is the long side, which actually matches with 20. 36 matches with 24, and 12 matches with 24. So if I go ahead and divide them, we're going to see if it works. Sorry, 12 actually matched with 8. There we go. Okay, so all of them are 1.5, so we all have the sides proportional. A matches with O, B matches with P, and C matches with N. Remember, when you're doing these to see if the sides are similar, you set up proportions to find X and Y, and all the angles should be congruent. Okay? For us to see if polygons are similar, not using shortcuts, you have to have the same number of sides, all the angles are congruent, corresponding angles being congruent, and then you also have to proportional sides. So angle C would match with angle N, which means they would be the same degrees. Okay? Angle A would match with angle O, which means they should represent the same degree. So if this was 30, this would also be 30. Okay, and then my last set, B, would match with this one, which means they would be the same degrees. They would be congruent.